Okay, very big welcome tonight to Pennine Ham's regular meeting online, and a very big welcome, of course, to our speaker tonight, Ignacy NO9E. Delighted to have you at our meeting tonight, and of course, a big welcome to those watching live on YouTube or those who catch up with us later in the week who missed it tonight because they're doing other things at work or any other activity. But are keen to listen to the speaker tonight. As lots of people who are regular members of our club and regular participants in our meetings will know, one of the big things that we are very, very keen on in this radio club is playing with antennas. And we've got quite a few people in the room here and in the club who are members who aren't here tonight, who enjoy building antennas, playing with them and seeing what works and what doesn't work, and very much enjoy doing that. And I think we've commented on that before in the club meetings here, that it's a lot easier to build an antenna than it is to build a modern radio. Certainly any of the radios to compare to the likes of what comes out of ICOM and Yaesu and the other companies that are producing these wonderful transceivers that we've got access to nowadays that are a delight to operate. Building an antenna is probably something that we can do, we can all do. It's inexpensive and it's fun and it's definitely worthwhile. So when I saw the article in QST, in February's QST, Ignacy, I thought I had to invite you to our meeting just to talk about the square beam that you wrote about there, because it seemed just such a lovely, simple, elegant variation of other wire beams. So I'm going to hand the microphone over to you, Ignacy, and let you take it away.
Thank you very much, Nick, for inviting me. Well, it's a privilege for me to talk to the club and to people from so many countries. I must say it's also a pleasure that I have operated from all of the countries here. So anyway, it's a familiar place. So let me go to my, presentation. Can you see it?
Yes, I can. Yeah, no problem.
Yeah, so I changed change the title a little bit because QST kind of does lots of editing over there, and then so I just my initial title was a beam that you can raise and lower in 10 seconds, and then so the title is kind of changed. And then I'm originally Polish, and I was kind of very active in all kinds of things, and then, for example, my first transmitter was done at the age of 17 with crystals kind of, let's say, secured at a military base without anyone's knowledge. And my microphone was also taken from a military, from a new military phone. So anyway, I do anything for the hobby. And I've in the US for 40 years now, and I've been perhaps operating from 60 countries so far. My goal is to do it from 100. So anyway, well, first, and lots of things that I'm talking, I may be preaching to the choir, so if there is something kind of too much, please perhaps try to sleep. In this case, I will accelerate. Or let's say you can ask me questions later on if I'm not very clear. So my regular home just has 2-element quad now for almost, let's say, 30 years. And then it's a pretty good one, and it has a, say, aluminum tower on top of it. It weighs just 5 kilos, but it has extensive reinforcement below. And also every year I make sure nothing leaks from the top. And then the quad is a three-dimensional figure. So if a boom breaks, it's lots of work, and then I would not like to do it alone. So anyway, lots of work. It works pretty well so far, and the only major failure was after the ice storm, where I had to replace a beam that was too thin. And there is a problem with this beam, that is nowadays there is so much noise, and noise also coming from the house, that while, I mean, why the beam is much better than a dipole, it's still not that good. It's in a bad place. It's a suburban location.
Ignacy, before you go on,
Yeah.
one of our viewers has said if you press F5, you should be able to go to full screen display on your screen here, because we've got only a relatively small picture of your display you've got
Oh,
here.
yeah, sorry. F5. Let's
I
see
hope
what.
that's right, George.
No, it doesn't work here.
That doesn't do it.
Let me try to exit show and try to do it again. I mean, definitely
Yeah,
need.
no, it's definitely worthwhile having it. I think if you go to the top menu and go to slideshow at the top of the screen there on the menu.
Let me do it. Thank you for letting me know. Having small pictures is no fun. So anyway, well, that quad was doing pretty well, but with extra noise was not as good any longer. So I'm faculty at the University of Georgia. I do extensive traveling, and whenever there is traveling, I travel to. I mean, I take my radio, I take a few days off, and this is Isle of Skye, for example. And then it was kind of a very bad place because it was extremely windy and it started raining, but I still made a few QSOs. And then it's another place, perhaps Cliff of Dover. And then pretty good for ham radio because it has kind of lots of space, say, from the south side. So anyway, and then about 10 years ago, I bought 10 hectares of land, 50 kilometers of town in the middle of nowhere, kind of in the middle of nowhere. It's mainly a hunter's paradise. And then came with old house here. And then, well, and then I wanted to kind of do all my dreams with antennas that I could do, and I hope for no noise. Well, it was not as easy as you know with any property. There is lots of work, lots of junk. Things don't go as good, and then the road washed out, for example. So anyway, lots of expenses, but anyway, there is space to do things. And my first commercial antenna was a 5-band spider beam. Well, and then what can I say about it? The spider beam weighs some 10 kilos, aluminum mast about 15 kilos. And then if I want to raise it myself, I mean, with the actuator, it takes half a day. So for example, 2 years ago, I found that the mast on the top is slipping. I have not done the fix. Why? Because I don't want to do that. It's not, say, that it's not that expensive, and there was no hardware damage, so at least that's good. And then I try, since I'm kind of don't have too much time, I try to make things as simple as possible, and then somehow hoping that things will somehow work. So, for example, you see the rotor here; it's on 3 garden poles, and what's the cable to the rotor? It's Ethernet cable, and then it survived 5 years. So anyway, it's kind of cheap and simple. And on the right, you see the attachment to guy wires. And I think this is attachment from ropes that go for clothing, for drying clothes. So anyway, and then it worked pretty well for a couple of years. Well, this is the spider beam, perhaps most of you are aware of. And then, let's say if we just look at 20 meters, it's 3 elements. But it's pretty big, 5 meters, 10 meters in both directions. So it's kind of unwieldy. You need to have space for it. And then my regular antenna, I'm a contester and I like to contest. So I put a tower. Well, at this time, 5 years ago, the tower was 10,000. I think now would be 20,000. Of course, you need to have space for it. 2 beams, 5,000 rotors, 3,000. I don't want to say how many guy wires and extra switches. Very, very expensive. Of course, you get what you pay for, and that is excellent performance. Say, so that now I expect to be heard. And then another tower should be coming. The problem is you see the trees in the back, and half of them are dead at this time. They're affected by pine beetle. So that's why I'm afraid to put extra towers, because once those trees hit the guy wires, my towers are gone. So anyway, that was working pretty well. And then perhaps just before I do go any further, perhaps I'm preaching again to the choir. If you look at the bands, you see declining single sideband activity. And then aside from weekend, many bands are kind of empty. And then I sometimes I call CQ, and on empty band I got lots of response. So it means that people could be active, but they are not. And then why? I mean, first we have high noise floor from electronics. I was in Taiwan at one time and visited one ham who had his house on the 20th floor, and his noise was S9. He only operated F8. Then there is restricted space. I mean, well, you cannot put better antennas, and then antenna restrictions. And those restrictions are basically keen in ham radio in the US. Every new house in subdivision has some rules where external antennas are not permitted. So you can put some wires over there, but it's no beam. Well, can you work stations? You can, if you have simple setups, you can work superstations. And then one very good example until last year was Sugar 57 DX. He seemed to be on the air 12 hours a day, but unfortunately he's dead, and his brother tries to make it, but only half time. And there are not many superstations on the band. So why are conditions that bad? Well, and then sometimes when I call CQ, and this will be phase beams, 1.5 kilowatts, and lots of stations replying, and they say, well, I have ICOM 7300 and have NFET antenna, and this works very well because I hear very well, and he gives me 5.9 plus 10. So I switch one of the phase beam off, and he says, we are 5.9. Then I switch to spider beam at 12 meters, and we are 5.7. I switch to NFET 5x5 to a vertical no copy, and this is all with 1.5 kilowatts. Well, what this kind of showing is that if we want to have kind of a luck, we need a beam, and then, well, 100 watts perhaps will make it. But of course, it's better to have more. So at one time, I needed an extra antenna fixed to carabines. This is for contest. I mean, if we are do contesting, we need to switch directions very fast, and then carabine has lots of multipliers. And they have one space over there, as you can see, it was used for a horse in the past. But however, it had high trees and falling branches. So if I put a regular tower, then say with any branch falling, there was a risk that the tower will also fall at the wrong place, would do lots of damage. So I was just wondering what to do. Can I come with something light and fast just to experiment? And then, well, so the question is how to create a light beam. So first you need a robust design, simple design, then strong elements, light wire, light spreader, light mast, light base, and light guides. And then I go over all of these points. So first we can look at geometry of two-element beams, and this is coming from a website of G3TXQ, who unfortunately is silent key this time. And then he compared regular Yagi, and this is the black, say, color here, two other types, and those four on the top. And then let's say hex beam now is very, very popular antenna commercially for a number of reasons, but the square beam is just as good and requires only 4 supports, not 6. So I mean, it's a green color, so you see the gain is kind of on top, and then front to back is kind of on top, and SWR is pretty good as well. So anyway, that's kind of a choice. And then a question is how to sustain the elements. And then we know of regular fishing rods. And then if they are made from fiberglass, they are not that strong, but there is carbon fiber. And they are much stronger, and they are as light or lighter. And then, well, how long pole do we need for 20 meters? About 3.7 meters. So, well, of course, the end is very light, so we can take 6 meters, for example, a 6-meter pole. It weighs less than a quarter kilo. Well, cut it, remove elements below 4 meters, and then 4 elements are less than 1 kilo, and they are very strong. Then we cannot put any heavy wire on the end elements because they will simply droop and they will sag. So, well, my choice is 0.8 millimeter wire, and then it's enameled, no insulation with that weight. And then it's for 80 meters, the end sags a little bit, 15, 20, 15, 10 don't make much difference, but anyway, that was my choice. Then there is a problem with carbon fiber rods. They are conductive. You put anything on that, it's detuned, and then you put kind of any wire that is close to it is detuned. So what I do, I used cable clamps, and these are cable clamps, and then I just push it over the pole, and then attach wire, to, let's say, to holes inside. And then, well, initially when you do tuning, you want these clamps to somehow hold, so I do paper clips for that. And then in the end, I do electrical tape. Is electrical tape good enough? Well, I'm not thinking what will happen 20 years down the road. This is experimental. So yeah, I care what happens in a month or two, but usually electrical tape lasts a long time if it's a quality tape. And then how to make a spreader, and then you sometimes see some claims of having extremely strong spreaders. Extremely strong, it means expensive, especially manufactured, and also heavy. I just made out of aluminum angle, and I think this is 1 inch size, so this is 2.5 centimeters, but 2 will work just as well, more is not needed. So what I do, I have 3 of them, each one about 1/2 meter. And then first I crisscross 2 of them and drill 2 holes, and then put a stainless screw over that. And then I attach one, let's say, to form an interlocking triangle. And then drill a hole and then tighten. And then due to interlocking, it's very strong and yet weighs perhaps 200 grams. And then what about the mast? Well, now there is a carbon fiber mast that is much lighter than aluminum mast. Well, of course, much lighter than anything out of steel. So 15-meter one weighs just 4 kilos and is much stronger than any comparable fiberglass mast. And it's fairly stiff. 10-meter version weighs 2.5. The problem is cost. And then I bought my 15-meter version for $600 a few years ago. DX Engineering took over, and they always add 30-40%, so it was 800. And with Trump, it jumped to 1,200. Very expensive, but if you buy it directly from Alibaba, I think it costs about 400. And then it's easily locked, unlocked, so you can easily manipulate. And 4 kilos is not much. Then, you need guy wires. How many? I'd say 1 on top. And then say how strong, how big rope do you need? And 1/8 of a rope can carry 200 kilos. Do you need more than 200 kilos? So if you have anything bigger than that, it's just for convenience. And then I use lots of Dacron ropes, and it never failed on its own unless it was rubbing something for a long, long time. Finally, we have some extras here, and one is garden pole just to attach our mast. And then we need to attach our guy wires to something, so we can attach to trees or something like that. And then if there is nothing, I use just dog spiral tie. And then it goes inside perhaps for 30-40 centimeters. And if the soil is kind of good, then you can't pull it off. And finally, you need to attach rope to something. So this is a carabiner, and a rope goes through that hole, and there is kind of a locking mechanism, and again it's working very well. It looks like flimsy, and then actually it's not. So finally you have a beam as you saw in the QST magazines. So in fact I made a 3-band here, and you have reflectors in the back, and then driven elements in front, and then you have insulating elements, and I just did it from Akron, let's say Dacron tape, no, let's say rope. And what else? And perhaps you see the attachment points. So these are those extra pieces. And then you see the spreader, and then see some attachment, and then for the wires, anything works here. At best, it's as light as possible. You can kind of fix your own attachment even without, say, as long as it weighs very little, it's good enough. So how does it work? So this is, you see it's very thin. You almost can't see it, and then it's kind of hard to see that it can stand alone. Well, and then you also see that the end elements are drooping a little bit. And drooping is actually good because it makes those elements better separated, and more separation, it means easy tuning and high bandwidth. So, well, you have the beam from a closer distance, and then, well, and I put some separation on 3 elements again to increase bandwidth. I don't know whether it's really needed or not. And I have a bit, another zoom here. You see attachment of the spreader. It's all done with clamps. And then there is a balloon here. It's not perhaps that well visible. The balloon is at the bottom. So it just 3 turns of coax through a toroid. And then if you measure the parameters, it's good enough. Well, and then you see on the left side the attachment of the of the pole to a garden, it says to that garden fixture. It's a little bit stronger than normal, and then I just attach it with rubber, let's say, with rubber devices here. And then you see the attachments of guy wires. So anyway, this is what it is. And then the question is about tuning. Should you tune it at all or not? Well, and then if you follow the directions as I did, and perhaps it works good enough. And then how can you find it? Well, it's always good to have another antenna, and then most likely you have another antenna. So if you point the antenna in the right direction, and it's louder, noticeably louder than your dipole, it means it's working. And then if you put it backwards and it's weaker, it means it's working. And if SWR is reasonable, let's say no more than 2.5 to 1, perhaps 2 to 1 is better, well, then your ATU in the radio can compensate for that. And then otherwise you just tune, and then there are normal rules for that you trim driven elements for best SWR. Also you can do it for best gain. And then, well, you need antenna analyzer for that, and then you trim reflector for best front to back. So in this case you have 2 antennas, and then you transmit on one, you receive on the other, you make measurements. And of course there is interactions. So I mean, if kind of the electrically the reflector is very close to the driven element, then the bandwidth is narrow, the gain is a little bit higher over a narrow range. If you kind of make the front to back at a lower frequency, then you find out that the say that the beam is more wideband. So I mean, one needs to know that. And then how can you kind of do front to back or gain measurements without working too hard? One can do it with wideband noise generator. So anyway, there is a wideband noise generator. And then, well, I guess if you attach it to an antenna, I mean, it can jam anything. I'm not sure whether using it is actually legal. Well, at my location, I did not care very much. But anyway, I attached that signal generator to the antenna, and then I received the signal on another antenna with a radio that has a pan adapter. It could be as easy as SDR play. And I used the flex radio. So this is the gain figure. And then perhaps just to show at the bottom, it's 14, 200, 400. So you see the gain kind of is fairly constant for wide range. So tuning for maximum gain is not critical unless you care for 0.1 dB or something like that. And then I turn the big beam around, and then what you see, this is front to back. In this case, about 35 dB, which is pretty good. And then I think over the range is about 20 dB, which is pretty good. I should not complain about it. And you see some extra signals because this is on a busy band, so other signals are present. But this way is very easy to tune if, let's say, your antenna is way out of tune and you don't know what's going on. And for example, you want to add 12 and 17 meters and things kind of, and then many elements goes out of tune. So anyway, with the noise generator, it's easy to do that. Well, how long did it last? So I expected the antenna to last a month, but actually, say it was pretty good for a year, didn't do something. And then after 1 year, there was a major hurricane in Georgia, after which many counties have not recovered. And on my property, you see, I had a number of trees overturned. This is the oak tree, but I think I lost 5 or 6 fairly large trees. What happened with the square beam? One element broke. Well, how long does it take to fix it? 10 seconds to take it down, but say it takes some time to remove the wires because they all need to go through that hole. So anyway, 1 hour. But anyway, since it's very light, actually it's a pleasure and then no danger whatsoever. So some comments here. Was also any hardware problem with it? And say yes. I mean, at one time I was say running in a contest to Brazil using full power with good speech processor, and then 10 meters stopped working. And what happened is that one clamp melted. And why did it melt? Because the wire is relatively thin, 0.8 millimeters, so it generates heat, and the heat just melted the clamps. And then, well, well, it looks like it's not good that the wires are heating. Can we do something? Well, for 10 meters, say we can actually substitute for a thicker wire, perhaps 1 millimeter, 1.2. And then since, I mean, they're at the beginning of the pole, on 20 meters, we don't have to do that, but that wire is longer, so the heating was not as much. And then let's say if we lose 100 watts out of 100 kilowatt, it's not a big deal. And this only happening when running Brazil for 1 hour. So, and then, so I mean, not very often. Then another problem is that my mast is not entirely straight because I just put it temporarily. So my antenna tries to turn in one direction. So I need to kind of take care of it. So you need to be careful. Then can we add 12 and 17 meters? I think you can, where they add a little bit of weight. So I would not use thicker wire on 17 meters or 12 I can. And we can even try 13 meters if we have 15-meter high mast. And however, I mean, we need half wave always for good performance. And then the question is, what would we use this beam for? So, I mean, would it be a permanent antenna? And it looks like perhaps not that much, because if you want something permanent, I mean, it's better to have a regular tower, put, say, elements with aluminum and something that will stand there for years. But if we don't have conditions and then you have some housing restrictions, it can be very good temporary antenna. What does it mean? Well, we don't need it, we just lower it so that nobody can see it. When you need it, you raise it. Does it take long? Well, a couple of seconds. What happens if it's broken? Well, it's easily fixable. Will it survive an ice storm? I'm not sure, perhaps not. But anyway, you can easily fix it. Then, well, it's also a very good antenna, portable. I don't know how would you do it if there is high wind, then one needs to somehow think about it. On the other hand, if the mast didn't break in during the hurricane, perhaps it's okay. Just for one person to put it up would be hard. And well, good for the expeditions. I mean, if you don't want to ship 20 boxes of equipment like many the expeditions do, and you do one man the expedition, can one at the rotor, perhaps one can at the bottom. I don't think how easy is it, because then it's kind of the attachment needs to be different than just a garden pole. Well, those carbon masts are pretty expensive. You can try to have aluminum masts, and this one is from Spider Beam, and 10 meter I think costs about $400. But and then I mean this reasonably light, 9 kilos, and then so you can possibly use it unless you have something else. And they also sell aluminum tripod, but it's $400 again. So you have both of these, and it costs as much as the carbon fiber mast. 15 meter, well, that's way too heavy. So, well, it's very good quality. You can put many things and heavy things on it. For fast setup, it's not good. Well, do I have anything else? Well, perhaps I show you my station, since perhaps I'm not running overtime yet. So lots of things here, but only few things that matter. So I chose Flex 600 radio. It's right here. And then why? Because potentially it's single operated two radios in one box. So it can transmit on one side and receive at the same time. Well, was it a very good decision? I'm not sure. I mean, it has so many faults, how many wrong things with firmware, new bugs coming out. So I almost lost my job trying to fix it, and lost my wife as well. So I cannot, perhaps now it became better, but let's say at one time I thought about burning it so that nobody else would be harmed by it. So I mean, and then still, I mean, the company is not serious. And for example, they advertise the single sideband signal as being extraordinarily strong, and because they have a special implementation of CESSB. It's compressed EESSB. It's kind of a technique that eliminates peaks from a single sideband signal and then allows for better compression, but it's poorly implemented. So in fact, the signal from this radio is 5 times weaker than from any other radio. So I mean, it's kind of a disaster. But anyway, very easily remotable. So this is what it is. And then I have some extra things. These are bandpass filters for contesting, another bandpass filter, and this is triplexer for, I mean, to kind of change tri-beams into signals for each band, so you can transmit on 10 meters and receive on 20. Say what it is. This is a phase. I don't use it. Tuner is at the bottom, and at the very bottom is flex amplifier. It's in a box because it's extremely loud. And then most of the switching is done through Wi-Fi using Green Heron things, and that it greatly reduces the number of wires coming to the shack, but also reduces the chance of a kind of effect of lightning on the shack. So anyway, this is what it is. And then I have lots of things in the on the property, and this is a box to beverage. And then I have beverages in 7 locations, and most of the design is very flimsy. Why it's flimsy? Because branches fall all the time, so I make sure that it's electrically good, but making it mechanically strong doesn't make sense, because I know I will fix it next month. I also didn't say that the antenna, the big tower, is loaded for 160 meters, and also it has wire connected Foursquare for 80 meters. Well, and then my last play is playing with EME, and this time just 2 times 4 elements, and then everything at the stations on the left. Yes, just for fun. If you have lots of property, you can do whatever you want. Nobody complains, and well, of course, only the forest is your enemy. Well, should I say anything else? Perhaps I should say that I traveled a lot. It might be information kind of interesting to you. And one of the places where I traveled was Easter Island. And there was an article in CQ magazine a couple of years ago about Easter in October. And unfortunately, my trip coincided with CQ Worldwide Single Sideband Contest. I was wondering, should I kind of start? And my wife didn't think it was a good idea. So I chose, well, anyway, this is the island, very, very nice island. And then if anyone has time, don't hesitate at all. And this is me, but with a very special setup. This is 12 kilowatt. So the radio is KX3, and it's actually very good radio. And then this is the expert amplifier that weighs 10 kilos and can be driven with 7 watts. So you have these two, and that's good enough. And then what did I have? I had a spider pole, 12-meter spider pole, and then attached end-fed antenna to it. But also I took some extra things, to have a beam. So what I did, you can see perhaps in the middle, there is a 10-meter beam attached to it. And then, the antenna was, there was a storm next day, the antenna was shaking, but the beam was fine. And how was the beam done? It was still the square beam that I showed before, but then it was made over there in 1 hour, using kind of the same idea as I was talking. And then these are the elements that I carry in my suitcase. So it's less than a kilo, perhaps it's half a kilo altogether. It's fiberglass, not carbon fiber at this time. Do I have anything else? And then on my property, before actually I did my regular spider glass, I experimented with fiberglass from carbon fiber just for 20 meters. And then it works pretty well. And then, but only one bend. When I tried to add extra bends, the whole thing drooped and then did not work. And then experimenting with this, I found that if I have wires close to the carbon fiber, nothing works. Well, so it was a good lesson. Do I have anything else? Well, this kind of shows the construction, and you see a BNC connector. As simple as it goes. I think this is the end of my presentation, so thank you very much for attention, and then I will entertain any questions or suggestions.
Brilliant. Thank you very much. That was very interesting, very enjoyable. You used the word experiment lots of times, Ignacy, and playing. And they're 2 important words for us radio hams. So let's just go to the meeting. Has anyone got any questions or comments or observations they want to make about Ignacy's design there for the square beam? Who wants to go first? Yes, go ahead, Ken.
Right, thank you. Yeah, I'll go because it's a subject very much to my heart, this, or in my heart. Right, Ignacy, thank you for the presentation. I'm looking at the wrong camera here. I wrote some notes down, but you answered them in the last few sentences. Apart from the first one, how does this differ from the commercial spider beam?
Yeah, so let's, okay.
And I haven't seen you with any measurements yet of the wire lengths. So how does it differ from the commercial spider beam? That's my first question. And then I just had some observations, and you answered them in the last few moments. Because I thought using carbon fiber poles would detune the antenna. And I put this down here, and also you said, I think it was in the section where you'd got comments, and you said when using unbalanced elements, I'm presuming your dipole element, that the rotator moved. Do you mean it induced RF into your rotator because you was using an unbalanced antenna? Because that's what I think that's what you meant. And I build antennas. I presently got a quad element up. I've had delta loops up, and I find that firstly, I don't like using carbon fiber poles for the obvious reasons, because I live near power lines and I don't want to use them. Secondly, I think that having built a 2-meter antenna using carbon fiber, it detuned it totally. And that's why I was a bit surprised. But obviously you say they are lighter poles and probably a bit cheaper, I don't know. So the question was about whether it's a spider beam in disguise, and I'm presuming that in the future, will you use fiberglass poles or continue to use carbon fiber poles? Ignacy, go ahead.
Yeah, so first with the spider beam, well, so I perhaps the sequence was a little bit weird here that I just added to the end. I did not want to overwhelm everyone with details. I wanted kind of the main message to come through. So the commercial spider beam, there are two versions. There is light one and there is a heavy duty. The heavy duty weighs perhaps 15 kilos. And then the light one perhaps weighs 7 kilos. Well, and then mine weighs 1 kilo. So what does it mean? I mean, if you want to push 15 kilos up or even 7, it's kind of a serious effort, and then you need to secure it very well so it doesn't, say, fall back on your head. If you have 1 meter, well, you don't care. And then the question is, how do the carbon glass detune? Well, definitely it will detune, and then if something is very close, it will detune more. If it's farther away, it does not detune much. And then what's going on? Let's say say when I constructed that fiber, say spider beam, then initially the driven element was on the carbon fiber poles, and there was no resonance whatsoever. So I separated it about by 20 centimeters, and everything was fine. And the question is, would still carbon fiber cause some trouble? So let's say that detunes a little bit. Well, if it detunes, well, you can compensate for it. Well, but say, does it cause any losses? It would if it causes any losses, the whole thing would heat up, and since this is likely to melt, but it does not melt, so it means it just kind of detunes a little bit, and that's it. And then the plus, so I'm for 2 meters, it's unimportant. For 2 meters, I think using carbon glass and carbon fiber is not important because the regular fiberglass is good enough. But for HF, where you need to have strong, say, poles that still are reasonably steep, 4 meters from, I mean, up, then the fiberglass doesn't make it at all, and carbon fiber does. So this was my first response. Second, why does the beam kind of turns in one direction? So when I was pounding my garden post into the ground, I didn't do it quite vertically. So the whole thing is a little bit bent, and I didn't kind of make effort to straighten it up. So what it is, if I were to do it again, I would kind of make sure that the post that holds the carbon mast is straight. And perhaps I should also say that, say, if the antenna is 15 meters high and then it's only attached to the post, if I don't use any guy wires, it still stands up. It's unbelievable. And why? Because the top is so light. But in heavy wind, it could possibly break or fall down. That's why I'm using the guy wires. And I think, did I answer all the questions?
Well, I just have this additional question. What do you think caused the clamps to melt?
No. Well, these were the nylon clamps.
Yeah.
So I mean, nylon has a low kind of the melting point, and then perhaps it's not the best material. I should have done it with something else from Teflon or whatever it is. But say when I have very busy kind of professional work and I go over there, either I do it in 1 hour, it's not done. So that's why it's kind of flimsy. But anyway, well, at least I identified what needs changing. But if you don't operate 1.5 kilowatts all the time using high compression, it would hold.
Okay. My final just remark is, I know you come from Poland, I think you said. It seems a lot of Polish amateurs are into antenna building, of which one very popular guy, Sugar Papa 9, I think his call sign's Whiskey Alpha, very well known with the delta loops. And I like a lot of the Polish design of antennas and copy a lot of them as well in my experiments.
Well, in old communist times, one had to be creative. So some of that carried on.
Okay, well, thank you very much for the presentation, and I'll pass it back to Nick. Thank you.
Yeah, thank you, Ken. Yeah, you've asked a couple of questions there that I want to put myself. But let's move on. Who else has got a question or comment or observation to put to Ignacy while we have him here? And I've put in the chat, by the way, just a copy of the article from the February QST for those that haven't seen it. So you can download it yourself and have a look, which obviously has got some dimensions in it as well. Right, anyone got a question, comment? Yes, Keith.
Yeah, good evening, and a fascinating talk, Ignacy. Looking at the design, to me, it looks like a super lightweight cobweb antenna, but 3-element cobweb. Would you think it's very similar size-wise?
Well, a cobweb antenna is really omnidirectional antenna. It's very compact. So what you have a dipole, and you make it kind of into a square. So what does it mean? I mean, with a very small radius, you can cover a couple of bands, but say it has two kind of disadvantages. So first, it's not directional, and second, it has very narrow bandwidth. So you need, I mean, I don't know how much. I mean, you need to use the antenna tuner, and then while this is kind of the say was a beam. So with two elements, and then if you have actually antenna folded, then actually the bandwidth increases relative to a regular dipole. So it's kind of a wideband, and in fact, the antenna has WR below 1.5. I think on most of, or definitely 20 meters and most of 15 and 10. So I mean, these are different antennas. But if one say is kind of restricted by space, that cobweb is an excellent solution.
Fine. And I do like your design, and I'm likely to build one as well.
Oh,
Thanks.
Yeah, thank you, Keith. Yeah, I think a bit similar. Ignacy, a few weeks ago, we had another US amateur, Hiroki, from the West Coast, gave a talk about a portable delta loop antenna made from wire. And his was for 2015 and 10. And at least two people in the club, me included, have built 10-meter versions of it. And of course, if you just built a single band 10-meter version, or perhaps 10 and 6 meters of your design for a square 2-element wire beam like this, it would be even smaller. And I suspect you could get away with not even using the carbon fiber material you're using. You could get away with standard fiberglass if you use the slightly larger sections of fiberglass. The kind of piece of fiberglass that goes into the poles made for tents that are fairly big tents where you've got fairly long poles going through them. I reckon you could use those, particularly on a smaller version.
well, I mean, if it's 10 and 6 meters, one can even try to implement the spider beam, and 3 elements is better than 2 elements. It would be more tuning. And I must say why I say like beam for, let's say, portable situation, if one can do that. And that is when I was on the Easter Island, say every 1 or 2 hours, there was S8 or 9 noise that wiped the band. So, and then it was coming and going, and I was trying to find out where it was coming from. I could not find it. Nobody spoke English on the site, and I still made perhaps 1,800 QSOs, and then I think was number 3 in South America. I would have been perhaps number 1 with that very simple setup if there was no noise. So if you have a rotational antenna, you can easily find where that noise is coming from, and then perhaps you can turn the back. Of course, in that case, you hope that the signals you want to copy are in front. So anyway, that's just my comment. And then also I operate lots of portable and from 6 countries. So what I do, I have a slingshot and then a spool of wire. It's usually 24 gauge. And then, well, if bends are high, I just suspend it from a tree. And if not, then I have a very small fiberglass pole. I think that when folded is 30 centimeters and otherwise is 5 meters. And then I just put 1 wire on it and have 1 radial. And then if the location is good on top of a hill, and then especially close to the beach, then it's good enough.
Yeah, you're preaching to the converted with our Ken G4VZV here, Ignacy. He's the man who goes down the beach with a piece of wire up a pole and has spectacular results working from Echo Alpha 5 on the south coast of Spain, right next to the salt water. That's the key to making these antennas work. But yeah, I mean, you've borrowed a lot, haven't you, from obviously from the amazing work that Steve Hunt, G3TXQ, did, who built optimized versions of the cobweb antenna and of course developed the hex beam. But I've got two questions actually I want to put. One is, did you find the coax around that single piece of toroid sufficient to block common mode current, number one? And the second one was just having 3 wires fed at the same point. And I know you you had to adjust obviously the length of each one. Did you find it critical in which direction you tune the wires from? So if you tuned the 20-meter wire first and then moved to 15 and then 10, that created a bigger problem than if you went the other way around, or didn't it make any difference?
I think, I mean, the way to do it is from the longer wavelengths, that is from 20 meters through 15 and 10. It took a couple of iterations, and then the question is, should you just do it with the beam at, say, 3 or 4 meters, and you kind of up on a ladder, or should you bring it down, then adjust the element and go up? And then if there are many elements, it will take some time. But I think I spent one afternoon tuning, and that was kind of good enough. But even with spider beam, I was tuning it at the commercial one, and I was never able to get SWR on 15 meters below 1.6 or 7. Why is that? I don't know. Perhaps I did not align something well. So, but anyway, well, the real kind of say picture is when working in a contest. So let's say I'm working in a contest, work in Europe, and then someone from Caribbean calls me. So I press a finger on the screen and switch to that beam, and his signal jumps from barely copy to excellent copy. And that's what I care. So this may be 1 dB worse than something optimal or something like that, but I mean, it's showing its utility.
Yeah, I mean, the spider beam, of course, as you know, and as Ken will know, is the standard spider beam is 3 elements, isn't it, on 20 and 15, and 4 elements on 10. So you'd expect more gain from it. But in your article, you didn't think there was a significant difference in practice between the 2 antennas, did you?
Well, I mean, there is slight difference. I mean, because say, let's say I have those beams, say on the big tower, 20 and 30 meter, and then I can say either look at each beam separately, or both of them faced, and then I can compare to the spider beam, and then this to the short beam. The short beam, I mean that square beam, and then this one is say is pointing to the Caribbean. So if I want to really compare, I need to make sure that it's South America or something like that. So anyway, say the square beam is slightly weaker than the spider beam. And why is that? Well, 2 things. First, it's 2 elements, and then it's a thinner wire. But I mean, let's say if let's say I work in a contest and I have antenna, let's say rotated in another way, then I gain 10, so I lose 10 dB. So anyway, here say whether if I'm 10 dB better or 9 dB better, it doesn't matter really. So anyway, it's working very well, and the question is how good is a high antenna. So let's say if I compare my 30-meter beam to 20-meter beam, so when conditions are marginal, when the band is opening, the high antenna is much better than the lower one. When conditions are okay, they are more or less the same. And then when conditions are excellent, it looks like the spider beam is as good as the high antennas, because the optimal takeoff angle is very high. So you can never say what's better, but say in contesting, if let's say you have up and low antenna, you can phase them together, so we have 3 dB extra. And then if there are any changes during the contest, they kind of get averaged out.
Okay, thank you for that. Right, anyone else with a question that they want to put to Ignacy while we have him? Anyone else tempted, apart from Keith, to have a go at building one?
Ignacy, pardon me, Ignacy. This is Steve, AA4BW. I'm not too far from you. I'd love to come by and see that in action someday.
Yeah. Oh, where are you located?
My wife and I live in Canton, just north of Atlanta.
Oh, yeah,
We're
perhaps.
almost neighbors.
Are you part of the Southeastern Club?
No, I'm active with the QRP club here in Georgia
I
and
see.
enjoy that quite a bit.
I see. Well, uh, many clubs, and we are not far away. Good to hear from you.
Well, thank you for a great presentation.
Yeah, thank you.
Yeah, and actually, Steve reminds me of an excellent point there, Ignacy, of course, that for those people that don't run high power but run low power, obviously, the better the gain you can get from your antenna, the better your signal is going to transmit, and the reception is going to be better as well. So for a QRP operator, and we've had another one apart from Steve, Anthony K8ZT has given a number of presentations to our club over the years online, and he is now exclusively operating on QRP, but was from until his antenna was very recently completely destroyed. His mast in a bad wind where he lives. He was getting extremely good results he's a contester in contesting using 5 watts, but of course the game was on the antennas. The game was the beam antennas he was using, and what you described about low profile antennas being more and more necessary nowadays because of antenna restrictions. Here in the UK, we face that even more powerfully because we've got fairly dense population in towns and cities, and it's very, very difficult to get permission or have the space to put up a beam antenna, on a big tower in your garden. But most people have got enough space to put up as you were describing, a small pole that's got a wire beam on the top of it, and if that could be put up and taken down, fairly quickly, so up for a weekend to enter a contest or to have some play because conditions are good, and then taken down again. That's a way of evading the problems we have with antenna restrictions, because we have them in the UK as well.
Yeah, QRP is not a good word for a high power contester, because you have a pile up and then you have a very weak station, and you think it will be a distant say DX multiplier, and it looks like it's someone running 1 watt with a piece of wire. So anyway, but I mean, I've been on both sides of the of contesting, and then if say in contesting, since so many contesters have excellent antennas, they can copy anything. So well, it's kind of fun to test whatever one has.
Yes, indeed. Yeah, that's exactly the point, isn't it? That's what we found here in the UK, because we've only recently had access as well to high power. So we were limited in the UK, full license holders, to 400 watts for many years. We've now got 1 kilowatt, although I don't think many of us ever use 1 kilowatt, even though that we've got the license conditions that allow that. But you're quite right. In what we find, of course, is when you're running, say, 100 watts into a wire antenna, you can still work these stations entering contests, because they'll work you because it's another point in the contest, and you can receive them and they can receive you, and that's the great thing about it.
Yeah, well, you remember Ballycastle, if anyone knows where it's in Northern Ireland. So they have kind of a walkway through the salt water, I say, and then on the beach, so you can kind of go over there, attach your your antenna to it, and operate from over salt water. It doesn't get much better than that, and the antenna, the signals are pretty good.
Yeah, I think that's at least another 10 dB, just that alone, Ignacy.
Yeah, at low angles, at high
Yeah,
angles.
indeed, exactly. Yes, with a vertical low angle antenna, at least 10 dB gain more, probably
Yeah, well,
more. I think probably more.
I didn't say that one time I set a 160-meter antenna on a beach, and then that was on Florida Island. And then I started hearing signals from Europe in bright sunlight. 2 or 3 hours before the sunset. And then just during the sunset, the Europeans were as strong as local people. I never have this experience with my regular tower. So the saltwater magic.
You've been reading Ken's articles, Ignacy. I think he uses those very words, saltwater magic. Right, anyone else got a question to Ignacy? If not, Ignacy, can we first of all just show our appreciation for a very, very nice presentation, and thank you for coming along. Thank you.
Very much.
Yeah, it was a pleasure, and I'm really pleased that you were able to join us tonight. And I'm sure we'll be hearing more from our Keith here. Perhaps Keith, if you get the antenna built and play with it, you can drop Ignacy a note to tell him how you've got on with it. And in fact, maybe we should write our own. If you do get one built, Keith, you should write an article for QST to send in to say you were inspired by the by their writer in the February edition of QST this year to build a similar antenna. And this is your experience up in the borders of Scotland.
We all benefit from each other.
Indeed. So with that, I'm going to turn the recording off, but thank you very much indeed. Been a great presentation. Nice to meet you as well. So I'm just going to stop recording and say good night as well to those of us watching live on YouTube, and those obviously who will be catching up with us later in the week.
Thank you very much for the invitation.